my god, that really is swept away.
Yes.
It's just kind of crazy.
Yeah, yours.
Yeah, I just remember being a bit anticlimactic from
Oh yeah,
but that's
You're right.
good.
That's how mine. Like my house is up like on the downslope, so it's like all the water. Just
Yeah, all the water to it, right? And then I was like, okay. Yeah.
All right.
Also, Dan may come back over because I suggested to Dan that since he's right there, he might as well just come back to present his lab report. So he may do that. But if he doesn't, he asked me to present his lab report today.
That'll be a first.
That's what I think that's funny.
Yeah, what is he doing? Like monitoring a lab or
He has TA like class right like in.
is it what does he do? Does he have to teach or is he just
I think
like
he's just like help. I assume he's just like monitoring them as they work. So I was like, why don't you just have one of us watch them?
yeah.
But
Does anybody else have experience with that? What is it? I don't even know what class that is.
121.
it's physical. I mean, like,
Oh, is it physical geography?
Yeah.
Oh,
I mean, like one of us. It would be for 5 minutes. One of us can just like make sure they're not cheating or anything. Like I don't think it would be that
And
hard.
then say like, just wait 5 minutes if you have a question.
Yeah.
But I hear that class, so I can read
Where is it? It's in
What class?
Geography 120.
Physical geography.
Yeah.
We could have started a little early. What time does this class start? 11?
Starts at 11.
Yeah, we could have started a little earlier. Okay. Well, you could be Dan today. That might be fun.
That's fine.
So today you are done.
Dan too.
What about Alana? Where's Alana?
I don't know. I've not seen a lot.
Okay. All right. Well, we'll get underway.
Where'd that one?
I don't know where she is either.
Wait, where's yours?
Mine?
Yeah.
I didn't have
Just
any like
Dan.
images or anything, but I have stuff to talk about.
Oh, okay. All right. Where do I go here? Well, let's do your own first, and then
Okay.
be Dan.
So earlier this week, I got the IRB stuff situated. I got back. They after a couple corrections, some which were less important than others. I got the approval. They said they sent back a comment as well, but when I checked it, it didn't show a comment. Like when I checked in the portal, it didn't show a comment. It just said that it was approved. So I'll see if they actually sent anything back. But otherwise, that was good to go. I created the contact list. I had the list of people that we set out, and I went and just found all their emails from like their university pages and stuff. So that is able to, so that is put together so I can send the recruitment emails out.
Okay.
I've been, since you mentioned, I've been trying to run the drone to map image of Rapa Nui. When I first tried to run it, I think because the image was on the NAS and the NAS kept disconnecting, there was like an error. So I tried running it again, and then it also gave me like another error. So I'm trying to run it again today, just to go get some to spit out.
There's always space on the D drive in there.
Yeah.
You need to create a spot you can run it.
I figured now that the NAS is like working, and it shouldn't be a problem.
Yeah.
But we'll see. I'll hopefully get that sorted today.
Okay.
In other news, I've been working on. I've been looking at like the journal submission requirements of like the journals and trying to format my thesis work. And this weekend I want to get I want to do some more reading as far as something that I want to include in like the background as part of the comparison to. I want to highlight more of the comparison from the traditional methods to like the new advanced stuff. So I've been looking more into like papers and stuff, kind of more detailing like how traditional archaeological practice is done. So I've kind of made that comparison. So I want to do some more readings for those, and then incorporate that into the background as well. So just work on writing that stuff. And then for plans for today is also finishing my the Acton Con report for Dr. Mixter and get that done. So that's on the plan for today. Yeah.
That was great. Yeah, that's a good list. Good. You want to try to be Dan? Let's be Dan.
Sure.
This is long.
He gave me the rundown.
Let's see how it goes.
Okay. So this week, Dan has worked on more Splat stuff. He's worked on more Splat stuff in DroneMap and PostShot in DJI Terra, as well as the conversion to 3D tiles, which is something that he, myself, and Buckman has kind of been looking at.
Okay.
So kind of going off that, Buckman and I have kind of been looking into this, and we've been looking at other services for this. Dan has been looking through Cesium Ion, which seems to be, based on what he has seen and what we have experienced, probably the best way to do this.
Mm-hmm.
So Cesium Ion requires a PLY file. It's like a web, like cloud-based conversion that can create the 3D tiles, which is important because in order to get something like ARC, you have to have them as the 3D tile format.
Cool.
So he's confirmed that it's working, but he has not been able to test it with actual georeference PLYs yet, which is part of his next steps of what he plans to do.
You did an amazing job, by the way. This is great.
Thank you. So as an extension of that, he's also been looking at the Splat function at DJI Terra, which is something that we've all kind of discussed about, which is in like the newer versions. So he's detailed as far as like in DJI Terra, when you're trying to create splats, that you kind of get the three. Compared to things like PostShot, there's a much more limited kind of scope of the settings. So you have the three kind of quality options: there's preview, high, and extra high. So he's kind of detailed of what those kind of actually mean.
Okay.
And also an export in DJI Terra, you can output directly as like DJI Terra's own Splat file format, as well as PLY files and the 3D tiles directly. And he's also mentioned that he has not actually tested this himself yet because he's been signed out of DJI Terra and needs to be signed in to access the Splat function. So that's something that he is looking to get fixed here soon. In other stuff, he's also been working on the Art of Science competition. So part of his work has been measuring the greenness and then converting that into a splat. So it's kind of an image on the right. So that's something he's been working on. So this is the code example that he's been using in order to do that. I can't really comment more about that.
Let me look at that. Hang on.
Okay.
Oh yeah, he described this to me. Okay,
Yeah.
Got it.
So this is kind of this is the drone to map mesh that he initially produced. I think this is his first run through. He noted that he didn't love the quality especially because the trees look kind of weird, which is kind of the focus of this when you're measuring greenness. So that's very important. So next he went to the splat. And he mentioned to me that the gaps on the bottom and like the ground layer it's kind of a weird rendering issue. Whereas if you zoom in close enough to the ground, like the gaps fill in and it's like it's actually there, but for some reason when you zoom out, like they disappear.
Straight.
Which I noticed was also an issue that I had. I think I presented on previously. It might have been at the end of last semester or the beginning of, I think at the end of last semester, it was when I made the DEMs and put them into ARC of like my Belize data, then when I zoomed out, there'd be just gaps of it missing, but when you zoomed in, it was there. So I'm not sure if that's just like an Esri weird, like kind of weird quirk in their rendering or something. Dan suspected that this is because, in this case, it's because Drone to Map filters out kind of like the cloud noise. So as part of that, it may just be removing parts of the ground. But I think that's kind of an interesting thing that warrants more investigation. So He's also been running it in post shot, which he noted would probably have the best quality as far as the splats is confirmed. Obviously, because it's the trees are better and also doesn't have the missing gaps that Drone to Map had. The one thing that he mentioned that he talked about with you is just the color schemings and changing the color scheme just to highlight the vegetation areas more. So this is one of his other options that he ran. So it was like a very dark orange, which I don't know. I don't think it looks very orange, but that's what he said it was set to. The next one was at a 50% gray, which kind of looks better, kind of looks the same as the dark orange. Then he tried it with a black, which looks better. And then the next one, he said was probably his favorite so far, was another black one, but with changed some of the other settings. And I don't know, I would agree that I think this highlights the contrast a lot more than the other ones.
Yeah, I think so. It's definitely the most visually engaging. Yeah.
Yeah, so he just had space for feedback. This is something he's still playing with, so he's not like set on any of these.
I would probably still, Dan, make a change where it's a little bit like the trees are a little blue, right? So blue hues are being used here, and I probably would stay away from that and really make it. And I might even stay away from yellow, right? Like I would make sure that it's pretty firmly within the green. Yeah.
Okay. I'll take note of that.
Brown.
In other news, so his goals is to finalize the color scheme that we were just talking about for OJ, and then just further work on the that art science submission, and then the last thing that he mentioned was getting the Terra thing sorted out so we could try testing the splats.
Okay. Yeah, we can do that. The Terra is still really limited on photogrammetry, even with the EDU version, like just straight image reconstructions are pretty limited. So I'm thinking about getting like a full subscription to Terra. I don't know. Like, it's tough. I mean, we have so many subscriptions to so many things that like we can't have them all. We don't use them all. You know? Even Cybercolor, like I think that subscription is like $3,000, something like that. And I don't know that we're going to get $3,000 worth of value out of that. I mean, I'm interested, right? Like, what research is about. Like, certainly, I mean, I'm fine with paying it once and let's see how it goes. But like, when we get to next November and we decide whether we want to renew it or not, I'm not so sure. But I mean, Terra is pretty useful. But the other thing about Terra is the version that we do have will be fine when it's paired with the LiDAR. So we will be able to make Gaussian splats with the L3 LiDAR.
Yeah.
Well, we'll probably just do that,
Yeah.
So I don't know if it's.
I would say that probably makes the most sense.
Yeah. Okay.
And fact of the week. I have not this thing he did not show me, so I have no idea what this fact is. Ugly Gary
Oh, I know this.
is a font created from the shapes of the U.S. House districts.
It's gerrymandering.
That's funny.
That's cool.
It's supposed to be showing how weird the gerrymandered house
Yeah.
districts are. I can recognize.
That's super fun.
That is interesting.
They're all Houston. No, I'm kidding. Houston's the one with the
Houston
worst.
through the years.
Yeah,
Wow.
that's pretty funny.
Cool. All right. Thanks. That went wonderfully. I'm so glad we did it.
All right, who's next?
We could have a contest where we just like you draw somebody's name out of the hat and you have to present that.
You get 2 minutes to read their slides and you're like, okay, present them.
I have a presentation, but I just I'm working on the part 107, so I'm probably gonna do like a lesson a week and then
You can do 3 lessons every day. That's what I did.
Is that true?
Are they?
Yeah, I'm really excited to do it.
Oh yeah.
I had to.
That's true.
Maybe
Because I
just
get,
stick your time.
yeah.
Yeah.
And then with the nuthatch stuff, I think because some of the data was harder to pull up than we thought. where Dylan and I are working on a new way to find the invasive species, but I think he's been a little swamped right now, so it's been a bit slow. But hopefully that'll pick up again. And I'm working on times to meet with him like every week, so it should be a lot easier to get like before I'd kind of like meet with him and then we would have like an issue and then it would be like a week and then I'd meet with him again. So hopefully it'll be a bit quicker this time.
Cool. Thanks. Oh, thanks, Alana's presentation.
Yeah, she said she'll be here in 15 minutes.
All right.
So, yeah, this week I've been working on my data, trying to make meaning out of it. Yeah, so I started with the point cloud alignment. So in the previous week, I only did the coordinate reference system alignment. And then so currently I'm working with 2 sets of data. That is the M350 and then the handheld data, because the new data is not yet ready. So after I did the coordinate reference system projection and everything, I brought it into Cloud Compare, and I realized that there was some minute differences. So I decided to do proper alignment again. So first I did it with using known points. That is using points that are known on both clouds as a alignment, and I use the M350 always as my reference, and then the handheld will be the one that I'm comparing it to. So I did it for the admissions and then the union area. That is what I'm working on currently.
Mm-hmm.
And after doing that, the results improved a little because I had a final RMS of 1.5 meters. So it was okay. Then I went further to use the ICP for the same data set, and then that gave me a much better results. So in fact, when I started earlier on, I did the known points, and then the results I furthered it with the ICP, and then the next set of data I decided to do only ICP without doing the known points, just to see if it will make any difference. And then when I did that, the results was much better. So I decided that then I'm not doing the known points again. I'll straight away do the ICP, because obviously the ICP is much better and way quicker. But for the P-squad, the P-squad scan that I didn't use RTK. So the 2 data sets were like all over the place. They didn't align because obviously the RTK didn't have any coordinate preference. So that's I decided to use the translate and rotate just to bring it much closer. And then from there, I did the known points because I didn't do RTK, I wanted to go through the process one after the other. Mm-hmm. So after using the translate and then the rotate, then I did the known points, and then finally the ICPs, and then now I think the alignment is quite better with that as well. But I had a discussion with Dr. Pingo, and he suggested I run some metrics on it to check for domain and stuff like that. So now that is what I'll be doing.
Oh, next?
Yeah.
Okay.
Yeah.
Got excited. I thought you were going to be on the next slide. So you have to turn that. Okay.
No, you're not going to be on the next slide, but next slide.
Sure.
Yeah. And then, so after doing the alignment, I decided to run some metrics on it. First, I decided to do the C2C, that was the cloud to cloud compare. And then when I started reading into the tools, they recommended that I should use the point cloud that has the most dense point cloud as my reference. But here is the case, the handheld is more denser than the M350, which is my reference. The M350 is my reference, but it is the other way around. Mm-hmm. So I decided to do the M350 as my reference and compare it with the handheld first. Then when I'm done, I'll swap it and see whatever if I'll find some differences. So I did that first as the first option, and then I think the result is good because the result is the image to the left, sorry, the right down image, and you could see that it identified that almost the 2 point clouds aligned perfectly to each other. There were no differences between the 2 point cloud except for portions of the roof of some of the buildings. So that's what I realized there. And then when I finished, I swapped them, and then this time around I used the handheld as my reference, and then the M350 as my compared. And then this image too, it's okay because you can tell that where the handheld couldn't reach are the roofs, and those are the places that got highlighted as differences. So now I think I'm okay using the M350 still as my reference because eventually it is going to highlight the roof as differences, which I can take them off if I want to, or still think through of what is out there.
Could I see option one more time? I think in either case, these big differences don't matter, right? Like we don't want to focus on the stuff that's at 10 meters, right? Because that's like errors and fragments of stuff that you don't really care about. So I would say bring your max of your color scheme to something like 1, right? So you're really focusing on like just where, because the roofs you don't care about, right? Like that's not the same. So, but it's good to know that you don't have to manually take the roofs off or anything, right? We can run it and we can get the stats. But yeah, try to bring you know what I mean? Bring that color map down to 0 to 1 is basically all you're going to look at. And if 1 isn't quite right, then you can adjust from there. Great.
And then with a handheld Gaussian splats to ACPO, like Leon said, with dance presentation, we started looking into it. So this from the cyber color, there's a splash from it. And then
Good.
when I was having the discussion with Leon earlier on, he made mention of a GIS box as one of the tools that he saw that can be used to convert the PLYs to 3D tiles.
Oh wow, okay.
So that if possible it can be.
I've never heard of this.
Yeah. So I decided to try it. So I got it downloaded and then tried to use it to convert the PLY to 3D tiles. I think it did the conversion okay, but viewing it in art didn't come up well.
Oh.
Yeah. So and then also the location was wrong. It didn't get a correct CRS, so the location was wrong. It is something.
All right, this is good.
Yeah.
Very helpful.
Yeah.
The splat was really nice. I mean, that looked very good.
Yeah.
Quick splat, quick scan.
Yeah, it was a very quick scan, 3 minutes.
Cool.
Just around the place, and then it was good.
I'd like to do. I think we could make these splats for all of the trails. Right, would be a good goal over time. I mean, for Nut Hatch particularly, this is coming up because we're really interested in mapping those. But all of the trails for all of the things.
I wonder what it would look like in a really dense, like natural and dense woods versus.
Yeah.
With the splats.
As long as you're as long as you're viewing it from a spot that's pretty similar to where it was gathered, they look pretty good.
I mean, yeah. I mean, I made some splats from the middle of the jungle, and they turned out pretty good.
Yeah.
As long as what you're interested in is not like out in the trees, but as far as like the main kind of stuff of what you're like focusing on, scan like turns out pretty good.
Yeah, and then
It'd be interesting to see. I mean, what would it take? You know, like a ground-based navigation of campus. Like when you're gathering your data with the handheld, you're kind of going around buildings, right?
Yeah.
And you haven't made like a splat of all of that together yet. I wonder how quickly it would take to get out of, because it is better when you're near the place that it was gathered. At some point, you reach a sufficient density that like it's all good. Like so, cyber color is supposed to be able to do. Isn't it? Can't it do a fusion of drone based and handheld?
It can, I believe.
Yeah. So Map Fusion.
Yeah, there's Map Fusion. Well, there's Map Fusion, which I think combines like multiple scans. And but I do think there is a tool where you can add like drone stuff.
Mm.
We thought about getting the more expensive X-Grids one that can kind of get mounted on a drone. But there's no reason why you couldn't mount the handheld that we have on a drone. So maybe that's an option to think about. I don't know, just possibilities.
Yeah, and just yesterday night I received my GISP certificate.
All right.
Now,
Congratulations.
officially, it has been confirmed.
Nice.
Yeah. Yeah, so my goals for next week or the weeks ahead. M3C2, I've been looking into it. It involves some calculation of normals and then a skill that I need to determine. And then I've been looking into it, but they were not so specific on what the skill should be or what the normals should be. But they were like, well, it should be large enough to do away with noise, but smaller enough to bring out the differences that you're looking for. So I've been trying to figure out which or what normal is going to help me a lot. I've run a couple of normals, like some like 1 meter. I've tried a half a meter. So I'll look at them and then maybe decide on bring it here and we'll decide on which one works better.
Yeah, a lot of trial and error with that stuff.
Yeah.
Very good. All right.
And a very short presentation just to have something to talk about. So I have a quick recap of last semester, how I'm moving forward with that. And also I was just reading up on HD mapping and I can just talk about things I learned. But remains. So the FRI project was never fully completed from a mix of Thanksgiving break and post-session deadlines. Like we completed it in the sense that we presented a final product, but all the initial goals were not, we didn't do everything we set out to do. So what we were able to do was we were able to chart the distance from trail versus the understory point density as with regard to the UAV collection. But there's a very weak correlation there, which makes sense. If you really look at the density, you can see the trails in some parts, but in most of it, it's mostly invisible. And the goal was to compare this with the handheld LiDAR, but the handheld LiDAR data we had was never geo-referenced, and the apples to apples comparison was looking almost impossible to really get. So moving forward, maybe just collect the data again in the spring, or see if there's a way to still use the handheld data that we already have, which is unlikely, but if that could work, then that would be interesting. So I was looking at HD mapping earlier today just because I was curious and this thing interests me. It's a fully, I don't know if it was discussed here before, I don't fully remember, but it's just a fully open source LiDAR mapping software that can run on a small controller is compatible with all these sensors. So it's just an open source framework that you can, kind of tape to the sensor, not really a 3D print a shell, or just literally put the Raspberry Pi on it, get it all wired up, and it should work, hypothetically. There's this one controller that one guy made, some hobbyist made, that's an open hardware implementation of the HD mapping software called Mandai. And he has all the 3D models, and there's some wiring using it's all Raspberry Pi is designed for, and a lot of wiring using the GPIO pins on a Raspberry Pi, which are like the general purpose input output that you can do whatever with. designed for tinkering and fitting into other use cases. The wiring work is not my expertise, but I can learn things. And the tutorials for it. So this is a pretty obscure project by one guy, and the tutorials are very low info manuals, and like time lapses of him assembling it and saying this is outdated, like as a so it's like it's very much figure it out kind of thing. Except the developer, there were recent commits on the GitHub, so it is an active project, and I'm sure he would answer questions as a if things come up. And the HD mapping software seems very well supported and developed. A lot of people are there. It seems like they were adding new sensors that it's compatible with all the time, and it's pretty cool, especially given the sometimes trouble that the proprietary software can run into using, especially with with the issues I was having with the handheld LiDAR. For example, I know that because it's kind of in its proprietary format where it kind of comes out as this finished product and it's hard to really get at what it's really doing.
Yeah.
This is a fully transparent software. So
imagine the goal of this would be an open source, open hardware version of that handheld Lixel thing. Cool. And we have
you can that number A or letter A is what it looks like with the Raspberry Pi in that shell. Yeah.
So we have that LiDAR in that drawer, and it's the same exact LiDAR that X-Grid's Lixel Kitty. And so somewhere in that Lixel Kitty is, it's a nice little shell, and inside that is something. Maybe it's Pi, maybe it's something else.
Yeah.
But there we should be able to replicate it. And then
also because it's all open hardware, you can 3D, like the CAD, you can 3D print it and attach it to any kind of mount or any. Though that guy has it on a dog. You can really put it on and he had it on his bike and things like that.
And then this one is one that we also have in the drawer, really high, super high resolution scanner, way better than what's on the Lixel Kitty. So that would be exciting if we can really wire that up. I didn't even know until we had talked yesterday that system was compatible with that sensor.
And this is just something I just was looking into this just as a review, kind of reviewing the literature. HD mapping has a paper published about how they made it.
Oh, you?
Yes, in a journal, which I read the abstract and yeah. So yeah, that's all I have right now. And I'm also thinking about any other projects I can do moving forward beyond this. Just that suits my interests, and that's where I am right now.
Well, good. Thanks, Owen.
This thing came up.
I don't have any presentation. I can verbally say that this week I'm classifying the point clouds again. It's taking a long time. When I'm saying it's 5 minutes, it's literally not 5 minutes. Still, I need 6 to 7 minutes to complete each. If there are many human, if there are 2 to 3, then I can complete it within 4 minutes. But at a time, I can do maximum 10. After that, I feel like, okay, I am done. I have to take break for 10 minutes and then I have to start again. Till now, I have done only 120.
That's good though. Out of a couple hundred, how many is that?
357.
Okay.
But I'm not kind of satisfied with what I have done because whenever when I'm checking, there are some points here and there. I feel like they're not correctly perfect. They're not perfect.
Yeah, and I would say don't worry about I think it's good to try to be pretty close, but there's diminishing returns on trying to make it exact.
It's taking time. I'm trying to make it smooth and perfect, but I don't know how much I can do it. Beside this one, I'm also looking at the LLM things. That means rendering the scene from the point clouds and trying to track it using different large language models like ChatGPT and Gemini. Basically, this tool can interpret well, but other than that, the rest of those cannot interpret well.
Good to know. Okay.
Yeah. If you ask me which one is the best, I will say definitely ChatGPT is the best one because if there are 6 human beings I can identify by my own eyes, ChatGPT tell me there are 5 and Gemini can recognize 4 like that.
Okay.
So based on it, I can say ChatGPT is working better than the others. And other one is Deep AI. It's not DeepSeek. At first I was thinking DeepSeek and Deep AI are similar. No, these are totally different. In DeepSeek, I cannot upload any picture or anything so that it cannot interpret. But Deep AI also sometimes it can give me answer, but most of the cases no.
Claude interpret images?
Claude, I have to buy the subscription for Claude. It
I
once
can volunteer my subscription.
Oh, there we are.
I have a subscription.
Would you send a couple to Owen and give him the prompt that he should send in?
Yeah, I can run it. I can run it on like the now Opus 4.6 that just came out yesterday.
thank you so
Great,
much.
thank you. And if it shows promise, then we can go further with that. But
Yeah.
let's see how it goes first.
This is all what I'm doing right now. Hopefully next week I will be presenting with thank
Good.
you.
Yeah, thank you.
But Priyanka, did you try Perplexity?
Perplexity, I don't need purpose.
Yeah, you should try it out.
Does it interpret the images?
Well, I've not tried it with images, but you can.
I
Because I know if you sign up with your student ID, sorry, with your student email, you get like a 1 year free subscription.
Oh, great.
Yeah, pro,
Yeah.
so you can try that.
How about this? I'm just looking here because my computer has like a button for Copilot.
Yeah. It's
So
Yeah,
Microsoft.
Copilot
Does
don't
it-
give me the answer.
it doesn't.
Copilot is just
It does not give me what I
it's
want.
ChatGPT with like a lipstick. It's the same model that's running it.
Is this a rapper?
Yeah.
I've never used.
There are lots of aspects.
That's a very good range, I think. With the addition of Claude, that was the one I was worried about, interested in.
Yeah.
Because they've been making a lot of progress on this.
So it was actually a little crazy.
Do
Yesterday,
that.
OpenAI and Anthropic announced new models within 30 minutes of each other.
Oh,
And they're both centered on AI. So the space is getting a little crazy, especially with regard to coding.
wasn't that Claude was made by these guys that used to work for OpenAI?
Yeah, I think so. But it's just Claude has made a name for themselves with being the best tools for programming.
Yeah,
Yeah,
I like it.
it's like it really is pretty impressive when you try to write software code that it's just like managing repositories and like writing like hundreds of lines of code. And it's kind of surreal. Yeah,
And you get unlimited for your subscription.
no. It's still rate limited even. My subscription I don't pay it.
There's
My
two.
friend
Like
my best friend from high school works at Anthropic and he gets to give 2 free subscriptions per year. So he gave it to me.
they're really pretty forced selection.
So I'm not paying it.
And all the very same use. Because using
I think Use AI is just a wrapper that like uses the APIs. But I have the I have the Pro, so I can get like it should work. Yes, you can do that whenever. Like I can just do that every time.
All right, we should probably continue so we can make the
Yes.
talk is at 12, so we'll,
Fine.
is that enough time? That's okay. Okay. Okay.
Is it just me that's left?
Yeah.
Oh, okay. Yeah, that's fine. So I just have some figures to show. I spoke to Peter a little bit. I really liked his figures for his thesis. So I spoke to him about his code and
Is what?
his Jupyter notebooks.
Okay.
He shared some of his code with me for one of his figures.
Mm.
So I kind of try to model the look of his a little bit with the ones that I'm going to show. So this is like 6 different ones, I think. Spent a lot of time this week in Jupyter Notebook. So here's just a basic one, just separating into 2 categories: the natural surfaces, so like grass, bare, tree leaves, tree bark, all that, versus all the built. And I also try to play around with colors and shapes. I stuck with like the X's and O's. You'll see. I would like feedback on how it looks, especially when we get to like when I break down like build categories, it might look a little like busy. So maybe ways that I can make it look a little bit easier to read. I just have like the basic regression line for all of these. Yeah. So this is the built surfaces. So I broke it down for each different type. The concrete was like gray, asphalt black, and brick brown, all circles, and then the other are X's. It's a little bit hard to see on there now that I need to choose my colors better, but I tried to like match the color with like what the actual like the gray concrete black. I like try to make it easy to read like that.
Yeah, nice.
This is natural.
Cool.
So X's for grass, bear, and sand, and then for trees I put that on its own as its own symbol. Always different colors. Then I decided to break up just two different surfaces against each other. So and I like this because it's super clear like how much hotter the turf is, and also the thermocouple and the infrared data. And we know this as it gets hotter, those temperatures stray away from each other, but it becomes pretty apparent with the turf.
Yeah.
How differently like those are measured. Much hotter in infrared.
I think one comment that I would make is I like the regression line in here, but I would also like to see a line that's like the even line, right? Like 10, 10, 20, 20, right? Something that connects up. So you can start to see like the, you know.
Okay. And then here's asphalt and concrete against each other. I had to make the regression line a different color. This is a little bit more. From my experience, I thought like the infrared was reading way higher than the thermocouple for asphalt, but like not really. Like a lot of them sort of seem aligned.
Well, it's not the regression line. This is where it kind of matters, right? So like if you're here, your infrared is measuring 46, but the actual temperature is 40, right? So you have to that's why that line is important, because then you can start to see how it's I mean it's 6 degrees or whatever the right number is, but and is it the hotter? I mean it looks like the hotter the more. Does that seem correct? Because 20 is 22, but 40 is 46.
Yeah. But yeah, because the turf stands out to me more, like those in the upper right.
Yeah. Well, so like if you're looking at this cluster is sort of in the middle there, actual 40 is measuring 50. Sure. Yeah. And so they are hotter, right? Like this is I think the interesting part. Like the turf is hotter than the grass 100%, right? But like it's differentially measured very differently, right? Whereas the grass, I mean, you take like thermocouple 25, grass 23, right? Or take 30 as kind of like 30, 30, right? Like this is almost square-ish in the middle, right? And at this point, like measured 33, but infrared measuring 31, right? Or something like that. So it's this, it's sensitive to both surface and temperature, right? And I think that's, to me, that's a really interesting finding, because all of these studies that are built on like urban heat measurements, like derived from infrared measurements without these corrections, are mismeasuring everything, you know?
Yeah, so yeah, these are all the ones that I made so far.
Cool. Is it all Matplotlib, or did he use Seaborn, or what did he?
I didn't use Seaborn, yeah. Matplotlib, there was like SciPy, there was like a regression, like first with SciPy. I forget what it's called, like inward regression something.
Okay.
Which I use to do the regression line. But yeah, Matplotlib and what's the other one? We used to have programming. No.
No.
Mm-hmm. Yeah, there's another one.
Pandas for the data.
Yeah.
Yes.
But yeah, everything is in the NAS drive. So if anyone wants to take a look at the Jupyter notebooks, they're all in there for each of these.
Peter got word that his thesis got major revisions. This was just a couple of days ago, so it's really exciting. So he sent it to remote sensing. So it basically means that if you make some corrections, it's likely to be accepted. Corrections are due, I think, on the 12th. So he and I met last night to sort of talk about how that would happen. It's really great news. Like, get your thesis published in a major journal. That's really great. So hopefully, all of you will do something like that if you're interested.
What are like major revisions?
There's really only a couple things that happen. You can get so when you submit it, a lot of times people just submit stuff to journals and that's not really applicable. So the editor will say like, he'll just take a look at it and be like, nah, and that's called a desk rejection. You're just like, I'm not going to get into the details of it, but like, I don't think this is appropriate for the journal, or it's like clearly not of high enough quality or whatever. So people just send, I mean, it's a big world out there, right? So remote sensing probably gets 1,000 articles submitted to it a month. And so the editor has to be like, nope, for a lot of the stuff. And then for the stuff that does get sent out for full review, then that comes back and each reviewer makes a recommendation, and the editor looks at that set of recommendations and makes a decision. And they can either accept it, which never happens, or they can say, usually the reviewers will say like, oh, there's a little of this, a little of that. That might come back as what's called minor revisions. Those would be very minor, like typically. And so then anything beyond minor is major. So it sounds bad, but there's no medium, right? Like if you could characterize what Peter got back, it's probably like medium, right? It's not a lot. It's just, yeah. And then beyond that is rejected, right? So, and then that happens with a lot of stuff like, oh, we just didn't like it or whatever. Reviewers don't have any problems with it. And then that happens, and then you can submit it somewhere else, right? It's not the end of the line. It's a lot like of the journals that could be a home to your particular topic, there's probably at least 5 and maybe more. So then you're just like, well, let me try to fix it if I think that's warranted. If I think the reviewers were just totally off base, maybe I just submit it as is somewhere else. And so one of the ones that Carl had just submitted about the Rapa Nui 3D model that he put together, I think that took 3 submissions to find a home for it, which ended up being +1. But that's a good paper and like got a lot of press, like, half a dozen news outlets like reported on it. So like it's clearly work that people were interested in. But yeah, even that one took time to get through. So
what's an example of like a thing that he needs to fix?
So each reviewer will have their own opinions. We looked at reviewer 2's comments as like it was the easiest review, and I think that they had said, "Oh, we wish you could." What was it that they wanted to talk about? There's something like, "Oh, you could have talked about this more in here, and then added in at the summary, but we want you to shorten the summary a little bit. The summary was a little bit too long." So that's a pretty easy couple of things to deal with. Reviewer 1 was like, oh, you didn't have enough background information on this particular topic, which isn't very specific, but it just meant, and in fact, Peter had like carved out a lot of his lit review so that it would fit within the journal's length. And so he'll just like dip back into his lit review and like stick some of that stuff in there. And it can range. I mean, they could be like, oh, you didn't, this, so figures, right, are another thing that comes up really often. For all of you guys, for the figures for your thesis, have a folder that's figure 1 and how you made the figure, the data that went into the figure, because you get something back that says, oh, I need you to fix this on figure 4. And if that's just in a pile of your muck and analysis, like, oh, it's so hard 6 months later to regenerate that figure. But if everything is in a folder that you need to make that figure, the Jupyter notebook, the whatever, like, and it's just like tweak go, then it's a 2-minute job instead of a half-day job of figuring out where it is and how to redo it, and be really careful with how you keep track. All right, we should over to the job stack, but thanks everybody. Thank you, Alana. Did we get to the goals? We did. Not really.
It's part of the progression stuff for the handbook that you gave me. Working on more.
Sounds good.
Yes. Just tell me what to put in. What's put in there? You can send me like the prompt and the images.